Hi, and welcome to the Many Faces of Code. The goal of this discussion is to show basically how important computer code is throughout the many areas of video game development, and also to highlight the diversity or the sort of differences between the different ways that it can be approached by different kinds of people. Because there's a lot of jobs in the game development industry, and even though many of them use code, we use them for very different things sometimes, or at least in very different ways. So we'll start with introductions. First, let me tell you a little bit about myself. My name is Scott Berkencotter, and I'm currently the lead engineer at Tan Army Gaming, LLC. We're the developers of the fast-paced competitive matching game Solceris. I've been an indie game developer and a freelancer since about 2007, and during that time, I've worked a lot in educational, mobile, and action games as well. As is often the case for an indie developer like me, I work in a lot of different roles as I'm making games, roles including both design and programming. So I have some of the habits of both of those kinds of people. For about 8 years, I've also been an educator at the Academy of Art University in the School of Game Development. I've taught programming to artists, designers, as well as engineers, kind of everyone across the board. I'm currently the programming lead there. And I also enjoy cooking. I used to rescue cats, and I just started my own Twitch channel for fun. Denmark.
Hi, so I'm Denmark Gibbs. I'm originally from Detroit, Michigan. I studied at Western Michigan University. Well, that's where I started learning how to program. I was a CS major for a while. I knew I wanted to make games, but there were no game programs at the time. So I ended up going to the Academy of Art, where I originally went to be an artist and then realized I was far better at programming. So I stuck with that route. That is also where I met Scott, and where I currently also work as a part-time instructor. Full-time, I work at Warner Brothers Games San Francisco. We recently released Harry Potter Wizards Unite last year, which I worked on. We have some upcoming titles that I'm working on, but they're unannounced as of yet. Yeah, that was it for me.
Yeah, so I'm Heather Gunn. I'm an author, painter, swordswoman, veteran game designer. I've worked on dozens of games for BioWare, Sega, 3DO, NCSoft, other companies. I've also self-published dozens more. I've designed for MMOs, action adventures, RPGs, fighting games, mobile titles, board games, and card games, and my own tabletop RPG. I'm a connoisseur of cheese, dice, fighting games, and media tropes. And I currently work at Enway on various fighting games, including Power Rangers Battle for the Grid.
Nice. Okay, so the way this is going to work is we're each going to share a story about how we've used code in an interesting or maybe unique way. And so I think I want to start with Heather. Heather, what do you got for us today?
Oh, yeah, sure. So you might wonder why a game designer is talking on a panel about coding. Me too. No, I'm just kidding. Actually, I started coding in 5th grade in BASIC. I eventually moved up to like assembly language, machine code, said, screw that. I've been since living in the land in between. So nearly every game design position that I've had, even as a lead or principal game designer, I've used code at some level in some way. So often as a game designer, I program in some, I use some sort of scripting language to create like character behavior, AI, level logic, world events. This is usually a proprietary scripting language. At 3DO, so there's a couple games I worked on at 3DO here. I used VikiScript, ICE. Those were totally proprietary languages that were invented by 3DO. At Sega, I used I actually designed the game logic encapsulation environment. I just wanted to be able to say we were making games with Glee. Santa Cruz Games, we had our own proprietary language for Critter AI. At Paragon, I helped design the language that we use to build world events with. On Battle for the Grid, I've been building their AI with an in-house GUI interactive behavior tree built in Unity. So the issue with learning, if you wanted to be a game designer and what kind of code do you want to learn, as a designer, there's a lot of different proprietary scripting languages or logic engines, depending on which company you're going to be at, right? So learning programming in general is a good idea if you wanted to have a good starting point. However, I was kind of thinking like, what kind of programming that I can talk about here that's going to be relevant to designers all the time, like all designers. So it came pretty clear to me that there are two specific programming languages that you could learn that would be helpful across a multitude of game projects. Number one, a prototyping language. Could be Unity, could be Unreal Engine. I know these aren't languages, just something to prototype in. Doesn't matter what language you're using. You know, Game Maker Studio, I use Game Maker Studio too for personal projects. It's pretty fast to get a project up and running. You know, but if you're interested in design, you probably know this part, and there's lots of YouTube tutorials out there. So I don't need to add to that pile. I'm sure you can find a game making studio program that works for you. And then number two, and I have to admit, I've used this on way more projects than I've used any other sort of programming as a designer, spreadsheets. I specifically highly recommend Google Sheets due to its ability to crunch and output mass quantities of data in just a single cell. You might say, well, that's not really programming. You'd be surprised. So spreadsheets are a really fast and intuitive way for designers to like make sense of data, design gameplay and economy algorithms, which is, you know, a very programming kind of thing. Reformat your data, which I do all the time. Generate large quantities of data. I'll talk about a few of these in turn. So here's an example of making sense of data. So Legacy Wars, one of the games I'm working on right now, has over 80 unique characters. So when I go to do a balancing pass on the characters, one of the things I want to look at is like win rates to get an idea like where to start. So when I grab the analytics, it contains a number of fights within specified parameters. So like players who are within, whose MMR is within X distance of each other, and sorted by winner and loser of that fight. But you can see here, like, you know, there's Black Ninja Ranger versus Black Ninja Ranger. There are this many fights. The first one is the winner, second one's loser. Red Ranger, with the shield versus Lord Draken. Red Ranger won this many fights. So some calculation has to happen in order for this to become useful data, right? So you can see here we got Red Ranger, Draken, and we got Draken and Red Ranger here. So if we add those together, we know how many total fights there were between these two characters, and then we can use that to figure out odds, right? But that sounds tedious. I don't want to do that by hand. That sounds awful. So I've got a little formula here. In one single cell, this purple cell here takes all of column D and E, or I guess D, and splits it into the two characters to get us started on our process here. And then we use some more complicated formula to turn that into win rates. And here you can see that we actually have win rates on a per character basis versus each character, which gives us a lot of kind of fine detail, which is great. And once I have this kind of data, now I can filter based on characters that are meaningful in the current meta, check win rates against those characters, do overall win rates like on a per character basis, so forth. Here's that formula in case you want to steal it. Grab it, it's going away. So, you know, when I'm doing 80 characters and I want to balance the game, you can't balance 80 characters in a pass. That's just insane. So what I'll do is I'll pick out a few characters with high usage and low win rates, and those are obviously characters that players care about, right? They want to play. They want those characters to work even if they suck. So those are good ones to like look at and maybe buff. Also, I look at a lot of like the very high usage rate, high win rate ones, because those are ones that players are probably complaining about, and usually they are. But having that data to back it up, it was really helpful. Here's an example of generating data and algorithms. So I use this sheet right here to design stats for ships in a yet to be released space fighter game. Actually, that's what's playing in the background right here is that game. It let me design a universal algorithm to generate different kinds of curves, linear, logarithmic, and hybrid curves. So you can kind of see down here at the bottom, we have a bunch of different curve shapes going on. Like this one is very linear, just going up by 1, whereas this one's more of a curve going from 1 and kind of getting reduced down towards a smaller value. and I can feed there's one formula here that I'm feeding 5 variables into to create that curve. So in case you want that, it's really handy formula. And I've used this in a bunch of different places now, but the fact that I'm able to just dump that that formula in here and then test out and see what those numbers come out to has been really invaluable in creating this game. What about formatting data? So here's a single cell. This monstrosity here is a single cell in an automated character sheet for my RPG. You can see, so here's the formula. That looks like code to me. And this is what the text that it's outputting into that cell. And then we can look at, that is the actual output pasted into my book. All I had to do was like change a couple bits of formatting to make that look like something intelligible. And you know, this is using spreadsheets to make our lives easier, right? You can see this is the data that it's culling from to create that, and it just makes it look sensible and useful. Using a lot of liberal use of filter, join, split, substitute. Learn to use those ones, and they all work together in such wonderful ways to make really complex, fun stuff. And you can see right here, like a lot of that. Anyway, skipping forward. In the past, I've also used Google Sheets to simulate the entire game economy of a game, step by step, to estimate player progress, day 1, day 7, day 100. You can see here, this is, well, maybe you can't see, it's really tiny. We have day 1, where is it? Yeah, day 1, all the way down here to day 14 at the very bottom. This is a dragon breeding game, and so you can kind of see over here which dragons have been bred, and there's like what steps the player's at any given point in time. This allows me to tune item costs, player rewards, etc., in order to make sure that the player still has content to earn at any given date in the process of the game. It also lets us kind of get an idea of like how long does it take the player to blow through all the content that we have? How much content do we need to be adding every week, every month in order to keep up with the player demand? So if you wanted to do game design and gain some very valuable designer skills, learn a prototyping tool, but also learn to do spreadsheet magic. That's my recommendation. So that's my little story, little blurb.
Nice. That's interesting. I love how you're using Google Sheets in a couple of different ways. One of them is very sort of math heavy, where you're analyzing a lot of data, which is obviously important. As a designer, you got to sort of see what's going on in the game and be able to make adjustments and that sort of thing. But also generating more or using it, I guess, as a tool to kind of design the game. So some of it's like going into the game. Here's some of the choices we could make. Here's some code that helps you do it. Others there's something already out there. Let's see how it's doing. Cool. Okay. Thanks very much for sharing that story, Heather. Denmark, you're up next. What do you want to tell us about today?
So I use code in a lot of different ways, but it is the primary function of my job to basically write code and write systems. So just want to show a couple of different things that I do like on a typical day-to-day basis. Although I can't show a lot of bug fixing, which is probably a good chunk of the time as well. Typically, my job is to use code to solve problems and basically create experiences. So at work, I might talk to a designer and we might build out a system to say, hey, we want this character to shoot in this direction while we're controlling him on the screen using a thumb pad or a virtual thumbstick. And it might be my job to either implement some part of that system, maybe just a virtual thumbstick, maybe just a shooting mechanic, or maybe the entire system from start to finish. There's a lot of collaboration in games, and I think it's, especially for engineers, it helps to be able to speak multiple different languages, if you will, not just programming languages, but like being able to talk to an artist about shaders or an engineer about spreadsheets or a designer about spreadsheets. All those things are very, very useful as tools of the job. So this is Unity. This is one of the prototyping tools that Heather mentioned. This is something that quite frequently I will actually use to prototype, or this is what I actually work in at work at WB. It's really good to get things up and running pretty quickly. For example, this little demo where I've got a guy in a scene, and everything you see was created by me. So in this scene, I can rotate the camera around. I wrote the code that does that. I wrote the code that zooms the camera. I also wrote the code that actually, so if we restart, notice there's nothing in the scene. This is basically what goes on behind the scenes in the game. When you're actually running the game, there's nothing on screen, and then it basically generates and populates this world. All that code is written by me, and I also wrote some code to basically describe where the character can move at any given point in time. So right now he can't move very far. Oops, that's not good. He can't move very far, so we're gonna extend that. So again, another part of the job is deciding or talking to designers and learning and working with them to tune certain values. So in this case, like my character wasn't moving very far, so I wanted to show him a better path. So we're gonna zoom the camera out, and then I can press the button to see like, oh, these are all the places my character can walk. And if at any given time I wanted to walk here, that's the path to get there. How I get to that point, well, we typically start a lot of our problems on paper. So this one is based on something called an A-star search algorithm. It's a pretty popular in games for AI to get from point A to point B. Once you have the algorithm, the baseline, what I typically do is actually grab a sheet of paper, write out the solution, write out how I'm going to approach the problem before I write any code. Once I actually have the solution written down, then I can go in and actually start writing code. So for this one involves a couple different scripts, one that generates the grid, another one that controls the scene. There's some code for the camera. So lots of different things going on at the same time, or going on at any given time. But once all that's done, then it's iterating and testing. So for this example, there was, like I said before, like there was initially it didn't move as far as I wanted it to. So also making values to be able to tune and going back and forth and fine tuning everything in any, during various points in the development process. The other part of my job isn't just to build systems, but also to make other people's jobs on the team easier. So for example, let's say I have an artist who wants to do something with an object, but placing it manually might be too difficult. So I actually wrote this system here, or this little tool here, that'll actually take any given object and duplicate it in various shapes and forms. So if I take, I believe it's this rock, boom, right now I can actually make a line. So I can duplicate this in a bunch of different spaces and increase the spacing on it, just because creating and duplicating this might be time consuming. And there's also shapes that you can't do perfectly. So let's say I wanted a grid. Okay, cool. I can have a grid with, again, increasing spacing between it. Let's say that we want to go a different direction. We can do that as well. Or I can even make it a 3D grid. This is pretty typical about where I would get feedback from another team member, create a tool really quickly, see how they feel about it, and then again, iterating. Like a big part of my job is building something, but then the majority of the time will actually be spent refining it, whether that is a system, whether that's a tool, or whether that's actual gameplay. Just going back and debugging and making everything work fluidly and smoothly and making sure everybody on the team is happy. So that's what I got.
Very cool. One of the especially cool things about this engine, Unity, is anyone can go out there and get it. And I think it's really cool that that's the direction that the game industry has kind of moved in. Anyone can just sort of pick this stuff up and start to play with it. And if the engine can't do exactly what you need, if you write a little code, you can make tools like the ones you're showing there, and that's pretty powerful.
Indeed.
When I was first working at the Academy of Art University, I was a computer lab technician, which means basically my job was to sit there and watch a bunch of computers. There was this tiny little room with about 10 computers hidden down in the basement, and that was my job, and I worked the night shift, and that was it. So needless to say, I had a little bit of downtime. There wasn't a whole lot for me to do. And so at some point, the associate director of the School of Game Development, his name's David Goodwine, he's now the director, he asked me if I could help him with a little project. And so what was going on there was he was teaching this class about 2D game development. And his vision for the class was for every student to make their own little 2D platformer. So we're talking things like Shovel Knight or Super Meat Boy. Basically have every student make their own sort of version of this type of game where you're running around and jumping and getting from point A to point B, maybe fighting some things along the way. Maybe you're shooting or smacking something with a weapon or what have you, right? And so it was a cool idea. It was, and that's what we're all about at the School of Game Development. We're about like letting and empowering you to make these games and to actually, take these cool games that you've probably been playing since you were a kid and making them a reality. But it gets a little bit tricky because David, my director, is an artist. He's not a designer so much, or a programmer. And there's a lot that goes into making a game that has to go beyond just what does it look like. And so the other tricky part about it was that we're using a tool called Adobe Flash. And these days you say Adobe Flash and either people sort of roll their eyes because it's something that's falling out of fashion, or they don't even know what you're talking about anymore. But from about 1996 to say 2011, 2012 maybe, it was a very common tool for game development. And that's about the time when this story takes place. It was about 2011. Definitely not a game development tool, even though it was often used to make games. And what you're seeing here are a bunch of games from kind of the 2000 era, 2000s. Even though it was something that could be used to make games, and people kind of took this tool, which is really more an animation tool, multimedia tool than anything else. They kind of took it and they ran with it, and they made some really cool stuff, like what you're seeing. But it took a lot of extra work to get this tool that was not really for games and to make it work for games. And so that's where I was coming into the story. So anyways, there was a lot that needed to be done, and Flash simply didn't provide all those tools to make even a game like this where you're kind of in the genre that we're talking about, right? And so a programmer was needed to make a lot of that stuff happen. And so if I recall correctly, basically the conversation was very simple. It was like, hey, can you come up to my classroom? I kind of want to show you something. And I was like, okay, sure. And then I go up to the classroom, and suddenly I'm talking to a bunch of students, and they've all got like art assets on the screen. They've all been sort of drawing, little characters or props or environments. And then basically David was telling me, okay, what I want to do is get them from these static images, and maybe some of them are animated. I can't remember, it's been a while. He wants to get them and actually put them into a game. And he wanted me to build something that would actually make that possible for them. So he's basically looking for some kind of a template that the students could kind of take all these things that they've been working on, all these art pieces basically, and just sort of plug them in. And that was what the class was kind of structured like at the time. It was, hey, here's how to animate, here's how to kind of, use the vector tools to draw your characters and those sorts of things. Oh, and by the way, we're gonna make a game with it. So that was kind of like, sort of an afterthought. But we wanted to see if we could make those things come to life. And basically, as I recall the conversation going, at some point I was like, yeah, I could do that. And he's like, okay, great. And so suddenly I was doing that because he was my boss. And that's how it worked. Which, by the way, is a bit of a life lesson. It's very important to say yes when you're entering game development. It's a very fast-paced career. You want to kind of show that you're willing to try new things and to kind of take risks and stuff like that. But it's also very important to know when to say no, which is a topic that I'll probably be revisiting because sometimes you can bite off more than you can chew. So knowing when to say yes as well as when to say no is very important. Anyways, the thing that I created came to be known as my platformer because I'm really bad at naming things. And the first version of what I did was actually really simple. As I recall, I think there were basically 3 layers that I wrote a little bit of code to parallax. And parallax is just kind of what you're seeing here, where it's different layers that move at different speeds to give you the idea that some things are further away, some things are up close. And so I believe that there were 3 layers of parallax, and then there was a player character, and that character could stand on objects in the front layer. Actually, I think there was even a layer in front of the player, so it might have been like the middle layer where you could walk on things. But anyways, you could jump around, and that was it. So you had 3 layers of parallax. You could jump from one platform to another, and I think at some point you hit a trigger, and that trigger said you win or something. And that was it. And that was basically the prototype of this thing that became my platformer, which is an important part in this sort of development process for designers as well as programmers. I want to say, prototyping and sort of building out a very quick and dirty version of what you're trying to do so that you get some ideas of how you're going to go about doing it but then you sort of throw that away and you do the real thing. And that's basically how it played out. Because for that first semester, when I created this thing, we basically had enough there to get through the semester, but that's when things got a little more complicated. The real thing, maybe we can call it My Platformer 2.0, came along the following semester, and it was a tool that we used for several years. I can't remember exactly when we stopped teaching that class because Flash, like I said, was kind of going out of favor, not really being used that much to make games. It's still being used as a tool for animating 2D characters and things like that, but to actually make the games, not such a hot tool anymore. But we did use it for at least, I want to say, 3 or 4 years, and the trickiness comes from the fact that the first time we ran it using this sort of parallaxing, really simplistic template, there was all kinds of ideas and sort of tools and things that people wanted to add on top of that. Oh, I want to jump and shoot enemies. I want enemies to shoot back at me. I want enemies to be flying around in a sort of parabolic path or whatever. I want enemies to patrol back and forth. I want to grab keys and unlock doors, like all those sorts of things that you think are really simple. You probably played a million games that have all those things, but you don't really think about how much work it is to actually make all that stuff. So by the time, we got rolling, and when I say we, I really mean me, because this was all me doing this work, building this template, there was already this sort of laundry list of features, and it didn't just come from, David, who was teaching the class, but it started to come from the students, and students were like, hey, I want to add this other stuff. Can I do that? And here we go again with me saying, okay, yeah, sure. Because I was like young and eager, and I just wanted to kind of be a part of something that was really cool. And it's not that I regret any of that stuff, but it did make life hard for a little while there. Anyways, as far as what it actually is, this is the tool. I still have it. This is Adobe Animate, which is what we used to call Adobe Flash Professional, was the name of the software tool when I kind of started using it. And basically, there's all kinds of reasons why it was really tricky to make this little tool. But I do want to give you a bit of a tour just so you can understand all the work that ended up going into this thing. So for starters, there's this sort of drop down up here where you can see the different scenes for the games. And so if you look closely at kind of how I structured all of this, the idea was, let's put some, we have a name for it. It's called programmer art. You just throw in some really, really basic graphics. You just sort of put things in the place where they're going to end up being. And then the idea was that the designers and artists who are taking these classes would come through and they would sort of click into those things and then, kind of replace them. For example, if we look back at the main menu, like this button right here, obviously really simple, but if I double click on it in Flash, you can kind of jump in and then you can say, okay, let's rewrite this. Let's replace this with a really nice hand-drawn sprite or whatever it is, or maybe even animate it. And I believe that on the bottom, you can see here that there was actually some really basic animations that I was just sort of throwing in there to say, hey, check it out. You don't have to stick with things being stationary. If you want to animate, all you have to do is kind of follow the guidelines for where I put the animation. And as long as you stick them in the same relative areas, you'll be fine. They can, someone could have these pop out of the bottom of the screen, and maybe they actually have hand-drawn frames where they change colors, or it could be any number of things. That was the idea anyway. Trickiness comes in obviously when you are adding code on top of that. So I'll sort of summarize why Flash is really tricky towards the end of this thing for what I was trying to do. But one of the things that makes it tricky is that there's so many ways to kind of program it. And I'm already sort of forgetting, okay, where do I go here? Is it right click, actions, there we go, F9. I was, Flash was my jam for quite a while, but I've forgotten almost all of it at this point. So for example, at the beginning, or I should say the end of the main menu, when it was time for that button to be clickable and for the next part of the game to open up, we have this code here that was sort of meant to make all of that possible. And so some of the tricky things that happen here are, okay, for one, things have to be named a certain way. So this one had to be called play button, and if anyone accidentally got in there and renamed something, then suddenly we're in trouble. The presence of certain objects had to be there. So, people, or I should say students, were often doing things like, hey, I want to get rid of this instructions button. I kind of want to do it in a different way. And so they would just sort of hit the delete key, and then it would go away. And then suddenly the code was looking for things that weren't there, and just all these little problems. And then in addition to like these little bits of code that are sort of basically embedded in the middle of animations, and those were not so bad because that's, you know, stuff that designers and artists could kind of wrap their heads around, even as students when they hadn't been taught how to write code or any of this stuff. This is ActionScript 3, by the way. Like they could wrap their heads around this stuff, but they also didn't really know how to make any changes to it. And anytime you have any code, you know, sort of running critical parts of a thing, if the designer decides that they want to change that thing, then suddenly there's all kinds of headaches that come up, right? In addition to that, we not only had code running there, but I had this whole set of code. Let me see if I actually still have it. Yeah, like I can show you this sort of hierarchy of this thing. If you go under game, you can see that there's about 10 or so different code files here. If you go into shooter, you can see there's another 4 or so there. If you go into adventure, there's a few there. And so basically all that was, a lot of this stuff was students coming to me with different genres of things that they wanted to do. People were happy doing platformers at first, but then they started to get a little bit, shall we say, greedy? I don't know if that's the right word, but you know, you wanted to do more interesting things. You wanted to kind of mix it up. You wanted to do more of the game that you had the vision of in your head. And so there was a lot of other code that was here. And so even just getting students to kind of wrap their heads around, okay, there's a certain like placement of things that has to be really critical. You've got to make sure that these folders are named a certain thing. You've got to make sure that they're always here. And so when I said, okay, you know, send me the file that is giving you trouble, sometimes I would just get this one file right here. And it was like, okay, well, I can't actually see anything happening because you've got these, you know, 20 to 30 other files that you need to include. So there's basically just a lot of things that were really complicated for students to wrap their heads around. And so it definitely became a little bit tricky to do that kind of stuff. And the further you go as well, like I think level 1 is where we see most of the actual gameplay. And I tried to like set this up. It's almost like a abstract minimalist painting or something, right? It's like, here's this one long strip, and you can see that clearly this green one is in front of the brown one, and that brown one is in front of the light blue one. And so I was trying to like set things up in a way where you would sort of step into it and see exactly what things were meant to be, and know that you could just sort of double click on this thing and say, okay, this was the foreground. So I just basically delete this whole thing, and then I replace it with whatever I want to have there instead. So if there's like trees passing in front of the player every once in a while, that's where they would go. Anyways. Long story short, a lot of this stuff was here, but then other pieces of it were also not here. Like, I believe that this is an enemy in the middle of the idle animation that you're seeing. Like he's got idle, move, jump, fall, and attack, as well as hit, and then death. And so I tried to kind of set this stuff up, and it all makes sense if you understand Flash, because this is how a lot of things work in Flash. You just sort of label these different parts of the timeline, and the animations are just sort of sitting there, and you kind of jump around in that timeline to play it. But again, we're dealing with students here. We're dealing with people who maybe had 5 or 10 weeks or even less than that, like understanding what this tool was, and suddenly I'm throwing at them, not only do you have to remember how to work with this stuff, but you have to do it in this very specific way that I set up to make all the code make sense. And if you don't do it that way, then suddenly the whole thing is going to break. Anyways, there's also things over here that you kind of had to go hunting for. Like, I can't remember how many times I had to explain to people, okay, when the enemy shoots a bullet, this is what shows up, this little projectile thing. And again, the idea was you come in here and you replace that with something that looks way cooler. And, you know, but it's just a lot of stuff to take in. So anyways, there's a lot of reasons why this got tricky, but there's also a lot of really cool stuff that came out of it too. So this is an example of a game that was actually built using this template. And not only that, but it's built by our very own Denmark, which is pretty cool. And so looking at this as an example, you can kind of see, you know, here in Flash, or as we call it now, Adobe Animate, like all the pieces are still kind of there, but they've been replaced. And that was the idea. So you got the idea of it. You've got the scenes that are still kind of in the same places. So here's his instruction screen. We've got level menu, which I don't think he ended up using. Like some people just didn't want to use the level menu, and that's an example of a thing that just got changed. His ended up being more of a scrolling shooter, which is actually really cool. And anyways, he got the idea of it, and he was actually able to make something super duper cool out of it, which I don't think I have time to really show you how the game worked. But basically it was, you know, your ship is flying upwards and shooting, and enemies are coming down, and he's even got power-ups and things that you kind of use to increase stuff. and get better at the game and that kind of stuff. Anyways, as far as the reasons why this was really tricky, I have three big reasons, sort of like overarching problems or things that went wrong here. One was my own inexperience. I was sort of a young developer. I think I'd only been working in games and making stuff for about 4 years. And that's kind of being generous because, I myself had been a student during the first 1 to 2 of those years. And so there's a lot that I was still really figuring out. But more specifically, I totally lacked the formal training of a programmer. I had taken like one class in programming, and some people can learn that way. And I even consider myself mostly a self-taught programmer because I did eventually find my way through this stuff. But that kind of programmer who hadn't had that chance to really do that is probably not the person you'd want building the super like foundational chunk of code that you wanted to have hundreds of developers using, which is basically what it was, right? So that paired with like competitive job markets and stuff is why we have 4-year degrees in games and why that stuff is actually really cool these days. In addition to that, my personal experience was in building little games as opposed to tools. And there's actually a very vast difference between those two things. Like you can build a one-off game with a really small team of like 3 people, which is what I was used to. But then again, going into building a tool that you want hundreds of people to be using for several years, there's a lot of forethought that you want someone to have going into that kind of stuff. And so it's just a very, very different beast. There's also things that are wrong with Flash itself. One, Flash really isn't a game tool. I mean, that's kind of the overarching thing here. It's famously bad for performance. There's things that Flash is just not good at. This is one of the reasons why Flash is dead, as some people say. Performance is one, security is another big one, but that sort of didn't matter so much for this. And so there were a lot of cases where, again, like we're basically trusting students who are not really initiated into game development to be using a tool. Well, maybe Flash was not the right choice for them to be doing that. These days, frameworks like we've seen, like Unity or Game Maker or what's another one? Construct is another one that's sort of good. They're all 2D tools, or at least tools that can handle 2D games like we were doing, and that's a much better flow that we have nowadays that we understand better. At least I should say I understand better, because maybe if I were a bit more savvy and I knew how to say no, I would have put my foot down and said, maybe having them do this stuff in Flash isn't necessarily the right thing. But that's also something that we were kind of learning at the time, because this is literally when Flash was in the middle of sort of being quote unquote killed. Anyways, there's other reasons why it's not good for the kind of tool we were making. It's not just like the problems that Flash is known for, but it's not tools friendly in a couple of different ways. One, like a lot of the work is done in this massive file, the FLA file, which you saw, and it can be several, like it can be dozens of megabytes. When you get really crazy, it can be even hundreds of megabytes. And so there's a lot of sort of trickiness that comes from having everything in this one giant file. It just becomes very cumbersome and hard to navigate. And then 2 is that there's no API for extending the editor. You guys saw when Denmark talked, a few minutes ago, that basically what he was doing was adding on to the Unity editor and creating extra little things that the editor didn't have built into it. And that's something that is really sort of key and pivotal to modern game development. I mean, really all game development on some level, like, because back in the early days, it was, we're going to make this thing and we're going to make it, and it's going to be exactly what we need for our purposes. Where nowadays we walk into something like Unity and it's like, okay, it does a lot of really cool stuff, but it also doesn't know what kind of game we want to make. So maybe we need to add a couple things to it. Well, Flash sort of had that, but it wasn't very good. It was very incomplete. And I, again, very inexperienced, didn't understand how to use it. So there's a lot of different ways that I could have made this a lot more interesting and more user-friendly more than anything. And then again, finally, not saying no is very important. I want to make sure I come back to this, because there was a lot of ways where this kind of just got out of hand. Feature requests kept coming in. Again, this is both from the instructors and from the students. And I just kept saying, sure, I'll do that, because I kind of just wanted stuff to do. But as a professional developer, you definitely have to learn how to not do that. That is, in fact, one of our jobs as an engineer, is to know when to say no and to just be realistic about, okay, these are the limitations on what we've got here. Let's stick within those limitations. Otherwise, we're talking about something completely different. Like, there's money that gets involved. Like, you're going to have to pay people to do it longer. You're not going to miss deadlines, or you're not going to hit deadlines. I mean, that kind of stuff. And then, like, people trying to do totally different genres, we just kind of really let that get out of hand. And again, it was like sort of cool to let students realize their visions, and there's a lot of good stuff that came out of it, but it just ended up being more work for basically everybody who was involved. And that's pretty much my spiel there. So, okay, so I kind of just want to wrap this up by just doing a little bit of back and forth question and answer. I've just got a few questions that I've prepared and wanted to kind of get your guys' take. So you're here now as representatives of design and programming respectively. And so I kind of want to just hear your different answers for these things. So my first question that I have for you guys is, when you're writing code, what would you consider to be kind of your top priorities? If you want to, we can say top 3 or something like that.
Yeah. Do you mind if I go first?
Go ahead. Go for it.
Okay. So I kind of used to be of the mind that, like, hey, it's a prototype, because, you know, as a designer, I'm not like, you know, I'm not making the game code, right? Like, generally. So just code it fast, hard, get it done, you know. But, you know, as I've kind of matured as a coder, I find that, like, actually having good coding practices can really serve you well, even when you're not making, even if you're just making a prototype, right? Like, you can save a lot of time by making reusable code, sectioning off bits of code into separate little chunks, makes things reusable. It also makes it a lot easier to find the bits of code that you're looking for. So, you know, my strategy nowadays is more of a, like, hey, let's think about it ahead of time and kind of architect it out and figure out, like, okay, well, how am I building this, right? Like, what pieces is going to go together? You know, again, going back to the spaceship game that I've been working on, I've been doing the code for it mostly. Started adding enemies to the game. That's actually what's flying around back here, is one of the enemies. And I ended up, like, I made an enemy and I'm like, oh, this is pretty cool. And then I copied it and, like, edited it and made more stuff. And so the way that Game Maker Studio has the code works is that when you make an object, you attach code to it, and the code will trigger at certain events. It's actually pretty cool. I like Game Maker Studio. It's really good. So I had this enemy that I created with a bunch of code already on it, and then I copied it and had another enemy that had the same code on it, and I started editing that code. And then I was like, oh, okay, I want to make another enemy, and I made a third enemy and did the same process, right? But then I got to, you know, I was fiddling around with some more stuff, and I wanted to, like, make sure that missiles could lock onto enemies, right? That kind of thing, and some other bits of things that then became universal enemies. And I'm like, oh, I have to go do this on all the enemies that I've made so far. That's going to happen all the time from now on. I need to go back and, like, make a single enemy and then have it, like, have, like, kind of universal functions. Mm-hmm. And then, you know, I point it at, like, here's an enemy definition, right? And then I don't have to worry about it. You know, if I want to change how enemies work, or if I want to add some sort of functionality to an enemy, or add, heaven forbid, like, a variable, I can just change it on one thing, right? I don't have to go find every single item. Especially now I think we have 4 enemies now, and, like, wouldn't have to do it on all 4 of them. So yeah, structure is really important. Like, thinking about ahead, like, how you're going to kind of build your game out, I think is really important. And then, you know, not even just games, but, like, you know, with the tools that I've been creating for in spreadsheets, like, I think that's also really helpful too.
Cool. Denmark, what do you think?
My approach is fairly simple. Make it work and then make it better. At the beginning, middle, and end of the day, if you write a feature that doesn't work, it doesn't ship. So obviously the first thing is to get it up and running. And then once you have something up and running, something that's testable, something that's, like, robust, then you want to make it, you want to improve it. You want to improve performance, or you might want to make, if it's a tool, you want to make it more usable, more editor, or more user friendly. There's always ways to improve. And part of that, of course, like I mentioned before, is bug fixing. Bug fixing happens in every phase of development, like, and across anytime you write a line of code that's not hello world, like, you're gonna potentially introduce bugs. So a big portion of that is, like, a part of that improvement process is just going through and squashing any bugs that may occur.
Yeah, that actually sounds a bit like my own sort of process too. I like to definitely get something up and testable very early. I think that's really key, to have something that you can actually see and touch and play around with, and then basically iterate on that until you get a bit closer to what the final product's going to look like. How important would you guys say that, or let me rephrase that. At what point, if at all, do you think about the performance of your code?
Well, I mean, or performance or just kind of how it's integrated, for future proofing or not future proofing, but like, basically a code debt, design debt, or whatever you want to call it, where like, hey, if I go in and I do this to it, it's going to save us a lot of time in the future.
Right.
I think Denmark makes a good point. Like, you get it running, and once you have something that meets the qualifications of what you're trying to accomplish with that code, that's when you can be like, okay, this is the way I want it to be. This is the action that I want to be happening, and now I can go in and like break it out into pieces, or build it more structurally sound, or look at places where maybe it's iterating where it doesn't really need to, or I can cut out some extra iteration loops or whatever to speed things up. I think that's about right. Or yeah, and if you have time, I mean, obviously, any project's going to be a bit different, right? If you're pretty much crunched for time and you need to get all these other functions in there, then sometimes you don't have time to spend time cleaning it up, making it perfect.
Right. Totally. So it sounds like you're saying it's not the first step, right? It's not something that you're thinking about as you walk into the code the first time. It's something that you can come back to kind of later once you have had some time to kind of get things up and running.
Yeah, but I mean, when I'm going into building something, when I'm going to like do my first implementation, I am thinking, or I'm trying to think of like, how can I make this structured nicely in the future? Or maybe even like, is there some stuff that I can do now that's really cheap for me to do, that would be sensible structure for future bits of content?
Yeah, and I imagine a lot of that comes from just looking at your previous experience and
Yeah,
remembering things that you've encountered before, and saying, okay, here's something that I can do, like sort of low-hanging fruit, where you say, okay, I can do something relatively quickly right now that'll save me a lot of trouble later.
Totally.
Yeah. Is it kind of the same for you, Denmark, or is it different?
It's a little bit different. I don't really have a choice when it comes to thinking about performance. Any piece of code you write like has to be performant because we work in games. So I mentioned earlier like the A-star algorithm. The A-star algorithm is prevalent in games because it is known to be very, very fast. There are other pathfinding algorithms out there, but they tend to not work well in games, either because of space complexity or because of speed. Everything we write in games has to be run multiple times per second. You think about your favorite game out there is running at 60 frames a second. That means 60 times per second this code has to run. And if that code takes a second to run, it's no good for a game. So even when I'm writing this stuff, like the just make it work part, I have to think about like, how much space is this allocation taking? How much memory is this going to cost? Are there other resources that this needs to either load, or because that's a huge one. It's like loading assets, any sort of file input, output, and of course, just like how long is your code going to take to run? So I always have to think about that, even in the beginning. Like, even when I'm just like testing things out, there are certain things I just will not do. For example, there's there are namespaces in C#. There's this concept of like grouping code, for those who aren't really code savvy. There's a namespace we're basically just not allowed to use. You can't bring it in. It might have a useful thing that you can use. You can't use it because it's slow. And so even when you're starting out, like, you can't use what might be a shortcut, because inevitably it'll cost you more time down the road.
Interesting. So you've got whole rules in place that are like very formally say, here are things that you were just flat out not allowed to use. Yeah, that's great. Yeah, and I think that is one of the key differences, at least for me, because I do, as an educator, often find myself answering this question of what is the difference between, scripting, which is what designers do as far as writing code most of the time. At least that's what we teach at the academy. And then versus programming or engineering code, where it's like, they're both writing code, and they might even be writing in the same language, and they might be writing using the same tools and all this stuff. And it's like, well, what is the difference there? And for me, I think one of the things that I always come back to is thinking about the performance in the long term of this thing that you're writing, thinking about writing basically code as a long-term service, and being, keeping all that stuff in mind from day one so that you make the best, most performant code you can. I think that ends up being one of the big things that comes back time and again. Okay, cool. My next big question here was, how would you describe your relationship with code? Sort of open-ended, but I think maybe Denmark, we can start with you.
It is mostly a love relationship. It's I don't know. It's a very tough question to answer. It is. I guess I could say it's the tool I use to solve problems or to overcome challenges or obstacles. Because that's essentially what it is. Like we write code because we need apps that do X, Y, and Z, that order cars for us, or order pizza for us, or order that sofa from Amazon, right? All those are solutions to problems that were solved by writing code. And gaming is no different. Like, I need my player to shoot faster. Well, I can go in and write a line of code that does that. I need to rotate my camera. Like, I can write code that does that. So I guess that's pretty much how I view code, is just as a tool to solve problems and challenges.
Okay, I like that. Heather, do you agree with that?
No, yeah, totally. That's basically what I use code for. To me, code is being able to code is like fulfills the promise of a computer, right? Like computers are meant to make our lives easier. Well, if you have a task that you need to get done that nobody else has made a program for already, right? Like, I can just code something.
Yeah,
that's
totally.
That's generally how I feel about code.
Yeah, totally. And that's, I think, one thing that I wanted to get across for anyone who is thinking about entering game development, is that there's a lot of emphasis in today's media about learning code. It's the thing of the future, and yada yada. Well, at the end of the day, it's really just one tool of many, which kind of leads us, I think, into our next question, which is a bit more specific. And the question is, how much time do you spend writing code on average in a week? If you want to answer in terms of percent, I guess. And then if you're not doing it 100% of the time, what are some of the other things that you do? Just so we can get across an idea of, okay, code is just one thing that we do, potentially. Heather, you want to go first?
Sure. I know it really depends on the stage of the game. So for a designer, like the life cycle of a game really kind of changes, like what you end up doing. I do end up doing lead on projects occasionally, and when you're starting out a project as a lead, like, there's not any code that you're doing. Like, at the very beginning, you're writing out documents and specs and ideas and one-liners, one-pagers, trying to build your razor or whatever, right? And even then, like, once you kind of get past that and you're like, hey, here's kind of what I want to make. A lot of times what I do after that is I'm building a board game, like, prototype idea, right? Or like, a pen and paper game or something like that, to kind of like, here's my thought process of like what the game should look like. Does it work on paper? I guess is kind of that point. But then after that, then it's either I'm doing prototyping, or engineers are doing prototyping, or some combination thereof. And so it starts to ramp up. My coding will go anywhere between like 20% to 70% of my time. A couple weeks ago, I was doing about 70% code because I was building an AI for a game that's coming up. And the rest of the time I was as a designer, I also write specs, and I fix other bugs that aren't code related, and I test stuff out, and have meetings, and there's as a designer, we end up doing a lot of different stuff and bouncing around between different kinds of tasks. So, like, yeah, but I think my top end was maybe 70% code.
Okay. And then so then is that sort of like, you're at the peak of the development cycle, would you say? Like, about how much time would you spend doing 70% versus the lower end of that range?
Again, it depends on the project, depends on what I'm building. When I was doing Battle for the Grid, like kind of in the early days of Battle for the Grid, like I was doing mostly story writing. So no code.
Right.
About midway through and near the end, I was doing kind of implementing, which isn't really code. It's more just like digging into data and putting values where they need to go, and then testing it and making sure it works. But then, and then a little bit later, then I was doing AI and I was trying to code, make sure that the enemies were interesting to fight. And so that then becomes, a 70% kind of thing. So it really just depends on like what kind of task I'm working on,
Right. Yeah, that makes sense. And would you say that that's kind of like a typical answer for a designer in your experience?
I'm kind of an all-round designer, so I do lots of different kinds of things. I don't think that's necessarily not necessarily a common situation.
Okay.
So other people in my studio, so we have a number of combat designers in my studio that like specifically they build characters. That's what they do. And I would say that that's they're building behavior trees and flow charts essentially. Like that's kind of like coding, but it's not really because they're using tools, but like close enough. You're not writing code, you're sticking stuff together and then putting variables and values and stuff like that.
Yeah, totally.
So that's kind of more on the programming heavy side of things. I have a system designer I work with very, very frequently, and he does mostly just writing specs, and then kind of digging in spreadsheets and building values. So like, it's heavier on writing. There's still some like kind of coding with the spreadsheet thing, like I was saying before, but so for him, I would say like 10 to 20% ish at most. Okay. So yeah, it really depends on kind of like where you're coming from. Before I've worked with a designer that was just all he was doing was writing, and it was just all writing and all creative like thinking. And that's not something you can have on every project, but the project that we were working on was like, it was a dragon breeding game, and so we need to have fiction for every single dragon in the game, and we need to have like, well, what's this dragon gonna kind of look like? Like you need to talk to the artists about that. Like, what's the fiction of like this delivery system that we're adding? What's the fiction of the place, this little cave down here? Like, what does it mean? And what are the fruits that we're growing and that kind of thing? And that was what he did. Like it was all writing. So
I think that's one of the things that draws a lot of people to design is just the breadth of the different things that you might find yourself doing in a given project. It's pretty cool. Thank you. Denmark, how about you? How much time do you spend?
My experience actually varies based on the time frame of the project I'm working on. So in the early stage of a project during prototyping, I'm probably doing like 95 to 100% programming like all day. If I'm in the middle of a project, or beginning of like writing a system for a longer project, it might be closer to about 80%, where the other percent of the time is, or actually I could probably say like 70%. The other percent of the time is like talking to people, being involved in meetings, making sure that we have all the information we need before we start on the project, or as we're continuing on with the current project. And then a good portion of that is going to be bug fixing, because again, as you write code, bugs come up. And then during the later stages of a project, especially towards the end when you're getting ready to launch, it's pretty much all bug fixing all the time. You might not write a single line of code in a day, and if you do, it's just to fix a bug. So it varies wildly just depending on the time of the project. It also varies wildly with level of engineer and the path you kind of take. As typically in engineering roles in certain companies, like you have the track where you go through like the tech director route, where you're still writing code, but you don't manage as many people. This kind of responsibilities increase. But then there's a path of like the managerial roles, where they write less code and they also supervise programmers underneath them. So it just varies, but depending on time of the project and level and type of engineer.
Cool. So, I mean, it does sound like, though, that at least most of the time it's not 100%, right? You're not just sitting there clacking away.
Almost never.
Yeah, totally. Yeah, I think for me, like working in really small indie projects and things, for me, it's like I'll be writing code and then I'll suddenly realize, hey, there's this design problem that just hasn't been dealt with. Well, now I got to deal with it because something's got to get done, right? And so there's a lot of that, just sort of totally switching roles in the middle of even a single task sometimes. And like, I actually find that kind of tricky sometimes, because there's kind of two different ways of approaching a problem. And I feel like I have to take half of my brain and kind of like set it aside for a second and say, okay, now let's approach this from the other side. Because there's often that tension between design and programming, where they come at a problem with totally different priorities in many ways. And they're both sort of representing the different needs of the project. And so you have to have kind of, sometimes, you hear it called like an adversarial relationship, where we're working together, but we're also sort of making sure that the different opposing conflicting needs are both represented properly by having sometimes hard conversations about what we can or can't do. All right, that's all we had for today. Thanks for attending Many Faces of Code. I hope you learned some stuff about the different ways that different developers approach code, and actually even some of the similarities between the ways different developers approach code. It's been a lot of fun. Thanks for coming.
Yeah, thanks for coming.
Take care.